So yesterday we actually covered about what exactly the set actually means. So it needs to be well defined and then also have distinct objects in it as well. Okay, then also I've introduced to you some set notation. Okay, and also lastly at the end of the lesson yesterday we learned how to go about describing a set. So there are three main ways of describing a set. So to continue with that, right? Okay, from the part where we learn how to describe a set. Okay. Just some things to note when it comes to describing a set. Okay, we learned that we can describe a set in words, and these are the elements in set notation, as well as to describe the set in set notation as well. Okay, however, it is not appropriate. Okay, just to a reminder. Okay. That when it comes to describing a set, you cannot write it in loose terms like this. Let's say you use your curly brackets, x is a positive even integer. Okay, less than 10. Okay, this is not a correct way of writing it, okay, because yesterday we learned that if I want to use set notation, okay, whereby this curly brackets is involved, then we will have to write it something like that. Right? This is a proper way of describing a set using set notation. Okay. Neither could we even do things like just say prime numbers. Okay, this is appropriate as well. Okay, so all these are not acceptable. Okay, now we move into talking about equal sets. Okay, just like how the word sounds, the term sounds. When we talk about equal sets, they are exactly equal. Okay, so there are two sets are actually equal if they contain exactly the same element. And we can write it as, let's say, A and B are sets, then we just say that A is equals to B. So for example, if let's say A is a set containing the elements 1, 2, 3, 4, then the possibility that B could be, it can be rearranged in maybe another different order, but the elements are exactly the same. Okay, so as long as elements are exactly the same, the order doesn't matter if they are what we call equal sets already. So looking at practice now 1B, we are given two different ways of how, two different sets, okay, C and D, being described in slightly different manners. Okay, so in part I, we want to list all the elements of C and of D. And then we want to check whether the number of elements are the same. And lastly, to check whether are the two sets actually equal to each other. Okay, so we are already familiar with how to actually list elements of C and D in set notation. Could I give you maybe about 2 minutes, okay, just to complete this question, okay, very quickly. Are we done? By the way, I do use a timer. Are we done with practice now 1B? Okay, the thinking time you don't have to do that yet. Okay, so let's look at practice now 1B. Right? Could I get maybe Ming San, could you tell me what's the answer for part I? What are the elements that you have in C?
11
Sorry?
11 to 17.
11 to 17. Okay. Alright, so hope that we are all getting this. Okay, for the elements in C, you have to list it all out because the question specifies that you list it out. Okay, what about D? Okay, what are the elements in D in this case? Josh. Josh is it? Okay. What are the elements in D? Say again? 10 to 17. Okay, so they are different then. Okay, let's go part I. Okay, part 2. Okay, are the two sets actually equal in the number of elements then? What do you think? Clearly it's not, right? Okay, because in set D itself we have an extra element. So in this case, are the two sets then equal? Surely they are not equal. Since they don't even share the same elements, neither do they have the same number of elements itself. Okay? If you want to elaborate further, you can say that 10 itself is an element of C, okay, an element of D, but not an element of C. Okay, but you could actually just stop and say that no, they are not equal because they are different elements. That's just good enough already. Okay, because we know that they are equal sets if they actually have exactly the same elements. But in this case, they don't have exactly the same elements. They have different elements. there's differences, so they are definitely not equal. Okay. So now I want us to turn our attention to thinking time on textbook page 4. I think it's purple, something purple on your textbook. Okay. So looking at part A, right? The question says that if A and B are two sets such that A is equals to B, okay, then the question is asking whether the number of elements would be the same or not. Okay, what do you think? I need to really carry my name around. Chloe Yu. Who's Chloe Yu? Yes. What do you think? If the two sets are actually equal, do they have the same number of elements? Yes? No? Yes? Okay, yes. They have to have the same number of elements, right? Since they are exactly the same, okay, they must have the same number of same elements inside, okay? So the number of elements must actually be the same. So clearly, answer would have been yes. If you want to explain it, we say that when two sets are equal, you can use the definition that they both contain exactly the same elements. Hence the number of elements in both sets will be equal. Okay? So what I'm trying to do in this case, when it comes to sets, right, don't just be solving question after question. Okay, we need to learn how to practice writing and explaining as well. Okay, so that's a skill that we have to slowly hone along the way, which explains why I'm touching on some of these questions. Okay, so in part B, the question says that if A and B are two sets such that the number of elements are equal, is A then equals to B? So it's phrased slightly different from part A. Part A's condition that was first given is that the two sets are equal, okay, then asking about number of elements. Now they reverse it, they say that the condition is that the number of elements are equal, asking whether, okay, are the two sets equal. Okay, so let's get some consensus or some comments from the class. Okay, how many of you would think that yes, the sets will have to be equal if the number of elements are the same? How many of you say no? Okay, why? Beside Jasper is Vanessa, is it? No, then who's beside Jasper? Sorry? Xing Xuan. Si Xuan. Okay, but I have a Xing Xuan in class, right? You right. Then we have a Xing in class, right? She's beside. Okay, and so is it Xing Xuan, right? And then Xing Ying and Si Xuan. Okay, remember. Okay, so Si Xuan, can you tell me why? Why do you say no? Sorry? Elements are different. Okay, so the question asks for a counter example. Can you give me a counter example? Do you know what's a counter example? So just give me an example such that the number of elements are the same. Three, four, five, six. Okay, great. Good enough a counter example already. Okay, so Si Xuan says that A is equals to 1, 2, 3, 4, and then B is equals to 3, 4, 5, 6. In this particular case, we see that the number of elements are equal, both of which are actually equals to 4. Okay, but then A and B are not the same because they don't contain the same elements. Okay. in mathematics itself, when you want to actually prove that something is incorrect, want to prove generally, okay, when they give you a statement like that, okay, usually what we can do is we provide a counter example. As long as we are able to provide one example, okay, that doesn't fit in that situation, okay, in that statement itself, then that statement will have to be false already, okay. So that's what we are doing over here. You don't have to say in a generic sense, okay, but I think we also want to be careful about how questions are being raised, okay, because it's not always whereby we can use a counter example. Okay, we can only use a counter example to disprove something, but we cannot use an example to prove something. Okay, I'm sure that along the way during your examinations and all that, you will have seen that if you give an example itself, it actually doesn't quite work. Okay. When you want to prove something, it needs to be mentioned in a generic manner. Okay, next, empty sets. I apologize if this chapter is very dry. Okay, because it's just filled with all the different terms. Okay, so for empty sets, right, I want us to consider, okay, the set A such that there are elements 0, 1 and 2, B, a set containing the element 0, and C, a set whereby there's nothing inside. Okay, in this case, for A itself, the number of elements will be 3. For B, the number of elements will have to be 1 because 0 is an element, okay? Whereas for C itself, it is an empty set, okay? The number of elements is 0. So an empty set, I mean clearly from the term, it just means that it is a set that has no elements at all, okay? So alternative terms that we use, okay, to describe empty sets, okay, we can also call it null sets sometimes. Okay, there are different ways to write or note or use notation to write an empty set. Okay, so empty sets, you can write it as really empty itself like that. Okay, or sometimes I can use this symbol phi. Okay, this is pronounced as phi. It's a Greek letter, okay, to say that C is actually empty. Okay, so those are notations that you need to be familiar with. However, take note that it is not correct if you write it like that. Okay, because if you write it like that, C itself is a set containing an empty set. Okay, so in this particular case, the number of elements in C is 1. So a set can contain set. Okay, so for example, our entire class over here, I can consider it as the set of 402 students. Okay, but I can have final sets such as the set of girls from 402 and the set of boys from 402. So in the big set of 402, I actually have 2 other sets, okay, which we will delve deeper when we go into subsets and all that later on. Okay, so this is a set containing an empty set. So let's move on. Let's take a look at practice now 2. I want us to give practice now 2 a try, given that P, Q, and R are being described in the question already. Okay, I hope that we are all familiar what consonants are. Anybody doesn't know what are consonants? What are consonants? Hello, what are consonants? Cheyenne, what do you think? No vowels, okay. So, please work out this question. I give you about 3 minutes. Will that do? If you have any questions, please raise your hand. I'll come over to you, okay? Okay, sorry, just to clarify, okay, one of your friends asked, how do I write an empty set in set notation, okay? So what you do is either use either one of these notation. Okay, this is where we're writing in set notation form, okay, for empty sets. I think I give you about 2 minutes more. we done? Okay, so let's check our answers, alright? So in part I, okay, I hope that you identify what are the empty sets. So P and Q are actually both empty sets. So to write it in this manner, or I notice some of you like to write it in curly brackets instead. That's also fine as well. Okay, R, is it an empty set? Is R an empty set? No, okay, it is actually, as I addressed earlier, okay, it is a set containing one element, right? So it is not an empty set at all. So we say that P and Q are the empty sets. Okay, then the question asks, are P and Q equal sets? So are they equal actually? Yes, right? Okay, because if they are empty, there's no elements. Alright, so surely all empty sets are actually equal sets. Then if Q and R actually are equal sets, so earlier on I've already addressed that R is actually a set containing one element. Okay, it is not an empty set itself. Okay, so they are actually not equal. Okay, so R is not equals to Q. Okay, let's look at exercise 1A, question 9. Okay, let's get ourselves used to reading, okay, set notation. Okay, for part A, is it true or false? I shall not read it out to you. Okay, true or false? What do you think? Let's see. Edith? Let's see, Edith. Oh, yes. False. Okay, so the question says if false, explain why. So how do you explain? Because C is an element. Okay, so in this statement itself, it says that C is not an element, so it is false because we see that C is an element. Okay, what about part B? True or false? Okay. Jovial. True or false? False. So why? How will you explain that car is not an element of the set? See again? Okay, so you can say that car is not an element, or you just say that since there is no element, in the set CAR, that is car. Okay? These are single individual letters that form single elements. This is one entity itself, car. Okay, so car is not an element of the set. Okay? It can only be an element if the set is written in maybe this manner. Okay? So do be clear about what is an element and what is not an element. Okay, what about part C, true or false? Ashley? Where's Ashley? True or false? False. Okay, why? Because what is a set? This thing is a set. Okay, so this thing is a set. It is not an element of this part over here. Okay, so he explained by saying that the set containing C is a set containing C. And then the last one. Okay, true or false? What do you think, Megan? Where's Megan? True. Is it true? So Xing is saying it's false. So then Megan, what do you think? False. That's like what? Okay. So we recognize that the tree over here is most likely trying to describe the number of elements in the set itself, but this is an incorrect notation to be used to describe number of elements. Okay. So therefore, we cannot have such a statement since we know that this is a set, but tree is describing the number of elements. Okay, you can say that tree is describing number of elements. Otherwise, you may want to also say that tree is not a set. Okay, since they are both referring different things. You can say that if 3 is written to be a set, then maybe there's a chance that they could be equal, but clearly we still see that they are not equal. Okay, since they do not contain the same elements. I want us to next give question 10 and question 11 in our exercise 1A a try. Okay, will you give it a try now while I write the question on the whiteboard? I give you about 7 minutes. How about that? Okay, let's check your answers. Okay, so I see that some of you are struggling in terms of finding the correct words, okay, the vocabulary to describe your sets. Right, so let's look at question 10A first. Okay, I think for 10A it isn't that much of a problem for most of you. You recognize that actually the elements are all prime numbers. Okay, so this is how we go about describing the set in set notation. Right, I think when I went around, okay, most of the challenge came in for 10 part B. Okay, your concern is about this number 0 over here, where you do not know where to place it. Okay, and then my question to you is actually, is 0 actually a multiple? Or what does a multiple mean to you? Okay, a multiple itself essentially, in this case, multiple of 4, okay, is when you take an integer to multiply 4 in this particular situation. Okay, so 0 is an integer itself. I can take 0 to multiply 4, okay, just that the product ends up to become 0. Okay, hence 0 is actually a multiple of all numbers. Okay, so 0 is a multiple of 4. So that's the first step that we need to recognize. Okay, so how do we actually describe this set in a more concise manner? Okay, because many of you are telling me that, okay, x is going to be a multiple of 4, and then you intentionally write down and maybe including 0. Okay, well, there's nothing wrong with writing that. Okay, there's nothing wrong to tell me that x is a multiple of 4 and including 0. Just say it's very lengthy. Okay, I wouldn't have marked you wrong actually. Maybe I will mark you wrong in another aspect lah. Okay, but there's nothing actually wrong in that statement. Just that it's lengthier. Okay, how do we make it more concise, more compact? Is that since you recognize that 0 is already a multiple of 4, all these numbers are going to be multiples of 4. Okay, we also need to recognize that multiples need not always be positive, they can also be negative. So negative 4, negative 16 and all that, they are actually all multiples of 4 as well. Okay, so to make it even more clear, okay, for this question, we say that x are actually non-negative multiples of 4. Okay, why do I need to put in non-negative? Because you recognize that 0 is neither positive nor negative. Okay, so non-negative will exclude all the negative multiples but include the numbers from 0 and then the positive ones. Okay. Alright, so even if this answer over here, it isn't quite sufficient, okay, because x are multiples of 4, you didn't exclude the negative one, okay, and then this statement itself also a bit strange lah, okay, because it says x are multiples of 4, then no comma, nothing at all, and then 0 less than equals to x, okay, usually maybe we say x more than equals 0, since we read from left to right, okay, maybe to complete it further, you can say and x more than equals to 0 lah, okay, then the statement will be more complete. And then this will actually have been acceptable. Okay. Then part C, I think you all just now very rightfully pointed out to your friend whose name I did not get. It is I called out who are the right hand man of Matthew, right? His answer. His name is Joshua. Okay, thank you. Yeah. So be clear about multiples and factors. Okay. So these are all factors of 12. Okay, I think most of you are able to identify them. Okay. Then usually also, right, okay, when it comes to describing, we usually write in singular form. Okay, if I get my grammar correct, okay. X is, because we read it as x is such that x is a vector. So every single individual element, that's what we're trying to describe. So we write x is a vector of 12. rather than x are factors of 12 because x is singular, not plural. Okay, so the accompanying grammar should be is rather than are. Okay. Next we look at question 11, shall we? Okay, question 11 I only got Harry to answer question 11a. Okay, because I think the rest is much simpler. Alright, so for 11a, okay, I hope that all of us are getting false as the answer. Okay, and Harry described that it is false because 0 is an element of the set. Okay, I think that this statement, will you agree with this statement? Will you accept this as an answer? What do you think? How many of you will accept this answer? Who would not accept this answer? Who's not sure? Okay, I guess the handless sign means that you're not sure lah, okay? And I only got one hand that says that you will accept this answer. I think that this answer, okay, is a bit ambiguous. Let me explain why. Okay, because when you say that 0 is an element of the set, okay, my question is which set are you talking about? In this statement, there are actually two sets. Alright, one set is this one containing 0. The other set is this empty set. Okay, so there's the ambiguity over there telling me that 0 is an element of the set. It can be this one or this one. Okay, so whenever you're writing an explanation, avoid having that kind of ambiguity. Always reread. Okay, could your words being chosen right actually point to two different things. Okay, so maybe to improve this statement, we can say that it is false, no doubt. Okay, as 0 is an element of the set. If you complete it with just this set containing 0, okay, which is not empty. Okay, you can emphasize it further that it is not empty. Okay, therefore it cannot be equal. Okay, then for part B, just now we have already acknowledged that it must be true. Okay, they both mean the same thing. I can write my empty sets either in this manner or this manner. Okay, they are definitely equal because both are empty sets itself. And then for part C, earlier on I have also addressed that this is not an empty set because it is a set containing an empty set. Okay, so how do we go about explaining this? We say that it is false. We can describe that this is a set containing one element, which is this. Okay, and then lastly, the number of elements of an empty set is equals to 0, so that's true. Okay. Questions? Okay, if no questions, I will give you the homework questions, okay, but I don't need you to do the homework, okay, because I want you to do it on Thursday when I'm not able to come in. Okay, don't need to so kanchong and do it. Okay, you can take your time and complete it on Thursday itself. Okay, Thursday I will ask the reading teacher to collect